Hello again, lovely people. Welcome back to part 2 of our walkthrough for the predicted paper, shadow paper for paper 1, which is non-calculator, where we have question 15, and our question is looking at surds. Show that 3 minus root 32 all over 1 plus root 2 can be written in the form a plus b root 2. So the first thing to notice is we have to rationalize the denominator. So we have 3 minus root 32 over 1 plus root 2, and that's all being multiplied by what we call the conjugate of the bottom, so 1 minus root 2. So we change that plus to a minus. If it were a minus, we would have changed it to a plus, and 1 minus root 2. So this is essentially an equivalent fraction because we're multiplying the top and bottom by the same thing. Okay, and another thing that I want to do before we multiply it out is change this root 32. So the square root of 32, I'm actually going to change it into this format, which is over here, because we can see that the format says b root 2. So the square root of 32 is going to be the square root of 2 times something else, which in this case is the square root of 16. Square root of 16 can be written as 4, so that's the square root of 2 times 4, or just 4 root 2. So the square root of 32 is 4 root 2. So I'm going to change this to 3 minus 4 root 2, all divided by 1 plus root 2, and that's being multiplied by 1 minus root 2 over 1 minus root 2. So to multiply it out, we expand it like double brackets. So I'm going to do that in a different color. Say like that, like that. 3 times 1 is 3. 3 times minus root 2 is minus 3 root 2. Then we do minus 4 root 2 times 1, which is equal to minus 4 root 2. Wow, different color in the fraction. Then minus 4 root 2 times minus root 2, well, that's plus. We need to do 4 root 2 times root 2. So the root 2 times root 2 is just 2. So it becomes 4 times 2, which is 8. So plus 8. The bottom bit is a difference of 2 squares. So you could expand it out the long way and simplify it. Or you recognize that it's the same thing as 1 squared take away the square root of 2 squared, which will then simplify. Again, if you need to expand this the long way, then you can do that. Okay, so simplifying the top, we get 3 plus 8, which is 11. And then minus 3 root 2 minus 4 root 2 is minus 7 root 2. And that's all divided by, well, 1 squared is 1. Root 2 squared is 2, so it's 1 minus 2, which is minus 1. Now we just need to divide both the top and bottom. Well, divide both bits by minus 1, because everything can be divided by minus 1. So 11 divided by minus 1 is minus 11. Minus 7 root 2 divided by minus 1 is plus 7 root 2. So we've got it in that form where a is equal to minus 11 and b is equal to 7. So our final answer would be minus 11 plus 7 root 2. Okay, let's move on to the next question. This is a nice question to have, on question 16. Wow. Wow. Right, so we have simplify 13a plus 2c. Okay, let's just make that bigger. So we want to simplify that. 13a plus 2c minus 3 lots of 3c plus 7a. Well, we have 13a plus 2c. Let's use a better color. Let's use blue. It's bolder, isn't it? Minus 3 times 3c is minus 9c. Also, minus 3 times 7a is minus 21a. So remember to maintain that negativity throughout. Funny sentence, that. 13a minus 21a is minus 8a. 2c minus 9c is equal to minus 7c. So that's our final answer. This is it. Next, factorizing. Ooh, look at these. I'm going to factorize this using my ultimate factorization hack. If you want to look up that thing, just type up Joy Colombo ultimate factorization hack. Okay, so to factorize this, we're doing 3 times 4. That's going to be 12. Then we need 2 numbers that multiply to give 12, but add to give 13. Well, that's going to be 12 and 1. So we can write this as 3x plus 12 and 3x plus 1. Now, note if you expand this bracket, that because you've got 3x times 3x, that's going to give you 9x squared, but we only want 3x squared if we were to expand this back out. So we divide this all by 3. Then I can rewrite this as 3x plus 12 over 3 multiplied by 3x plus 1 over 1, because this multiplies out. Then we can see that we only cancel out this left fraction, where we can divide everything by 3. So that becomes x plus 4. And then the 3x plus 1 over 1 just remains as 3x plus 1. That's the factorization. Let's apply the same technique to this next one. So 5x squared minus 13x minus 6. So 5 times minus 6 is minus 30. We need two numbers that multiply to give minus 30, but add to give minus 13. That's going to be minus 15 and plus 2. So we have 5x squared minus 15, not 5x squared. It's going to be 5x minus 15 and 5x plus 2. Again, 5x times 5x is going to give us 5x squared. That's what I was thinking of. But we don't want that, so we divide by 5. Gives us 25x squared, sorry. But we want 5x squared, so we divide by 5. So it makes that. And again, by the same logic as before, 5x minus 15 over 5 multiplied by 5x plus 2 over 1 works like that. And then 5 divided by 5 is x, minus 15 divided by 5 is minus 3. So it's that multiplied by 5x plus 2, all divided by 1 is just 5x plus 2. So that's the factorization for that. Moving on, we're going to simplify this. So again, this is quite easily simplified, but I want to explain how this works and why this works. So this is the same thing as 2 lots of x plus 3 times x plus 3, all divided by x plus 3. We can rewrite this as 2 lots of x plus 3 multiplied by, and that's over 1, multiplied by x plus 3 over x plus 3. And then that will simplify. So this part, because it's one thing divided by itself, it's just 1. So really, it just leaves us with 2 lots of x plus 3 over 1 times 1, which is just 2 lots of x plus 3. I mean, some people probably saw that from the beginning, in which case that is absolutely fine. This is just me explaining why it happens. So if you saw this bit straight away, that is all good. Next, we're simplifying this. So we need to factorize before we can do any simplifying. So we need to find two numbers that multiply to give minus 4 and add to give 3. So this one's one of the simpler factorizing for quadratics. So two numbers that multiply to give minus 4 but add to give 3 are plus 4 and minus 1. So we have x plus 4 and x minus 1. And then for this other fraction, it's going to be two numbers that multiply to give 7 and add to give minus 1. Well, that's minus 7 and minus 1. So x minus 7 and x minus 1. And we can write this as x plus 4 over x minus 7 multiplied by x minus 1 over x minus 1, in which case we see that this simplifies to 1. So we're just left with x plus 4 over x minus 7. Let's keep it moving, guys. Right, next, the nth term of a sequence is n plus 1, n plus 3. Work out the first 3 terms of the sequence. So first 3 terms basically means substitute n equals 1. So that's going to be 1 plus 1 instead of n times by 1 plus 3 instead of n again, plus 3. So that gives us, what, 2 times 4, which is 8. So the first term is 8. Next situation is when n equals 2. So we have 2 plus 1 by 2 plus 3, which is 3 times 5, which is 15. Great stuff. Then the next situation is when you have n equals 3. So that's going to be 3 plus 1 multiplied by 3 plus 3, which is going to be 4 times 6, which is equal to 24. Look at that. No expansion needed. Those are our final answers. Some people prefer to expand the brackets. Oh my gosh, you do not need to do that, guys. You really don't. Right, next question. James, number 20. James has X pence. Hannah has 5 pence more than James. So Hannah has what, X plus 5? And then Liam has 2 pence less than James. So Liam has X minus 2. The total amount of money they have is 75 pence. Use this information to write down an equation in X. Okay, well, so if we add up all of their amounts, that's going to be X plus 5 plus X minus 2. And that is supposed to equal 75. So if we simplify the left-hand side, we get X plus X, which is 3X. 5 minus 2 is plus 3, and that is equal to 75. That on its own is great. That's enough to write an equation. 3x plus 3 equals 75. So that we can see the whole question, let me just make this a bit smaller. Oops. Okay. Let's do it like that. Why doesn't it allow me to get it bigger? Come on, yes, there we go. All right. And then the next question says, solve the equation to find out how much money James has. Well, that's okay. Enough, I think. So 3x plus 3 equals 75. We're going to subtract 3 from both sides, giving us that 3x is equal to 72. Then dividing both sides by 3, we get x is equal to 72 divided by 3, which is 24. So James was X, so that's going to be 24 pence. Next question, we want to make W the subject of this formula. So this is quite nice. So we just multiply both sides by W minus 5, a bit like cross multiplication again. We don't like to work with fractions typically. So where we can avoid them, let's do that. So we have G multiplied by W minus 5, and that is equal to W. Expand the left-hand side, we get GW minus 5G, and that is equal to W. Then what we're going to do is, well, what I'm going to do at least, is I am going to just subtract GW from both sides. So we get minus 5G equals W minus GW. Now, what I've achieved here is I've gotten everything with W on one side and everything without W on the other side. Because now what I can do is just factorize out the W. This cool magic bit. So W, open bracket, 1 minus G. Now we've only got one W that we can see, which is nice. And we can divide both sides by 1 minus G. So we have minus 5G over 1 minus G is equal to W. By the way, if you tried this question before I did, you might find that another way in which you can express this is this. So times the top and bottom by minus 1, you get 5G over G minus 1. That's another equivalent way. So this is acceptable as an answer, but also this is acceptable as an answer. So I'll let you choose which one you want to write on the answer line. Okay, next question. On the grid, clearly label the region which satisfies all three inequalities. So x is greater than 0. So first of all, there's understanding when do we draw a solid line and when do we draw a dashed line. So whenever you see an inequality like this, that means we draw a dashed line because it doesn't include that bit. And when you see an inequality like this, we draw solid lines. So this one's going to be a dashed line. Right, let's start with the red one first. Is that red? That's not red, is it? That's close enough. Okay, so x is greater than 0. Let's draw the line x equals 0, which is actually going to be the y-axis. So I'm going to draw that. Let's get that ruler close. Let's do it like this. I think that's like fine, but let's just go overkill because I like to do that. Okay. And then y, let's draw the line y equals a half x. Let's draw that in green, or that green color. So y equals a half x. Well, when x equals 0, y is 0. When x equals 1, y equals a half. When x equals 2, y equals 1. When x equals 3, y equals 1.5. And then I think we've got enough points there to start drawing some points, I think. I think that's okay. Yeah, that should do. And me trying here to draw it like as best as I can. It's not going through exactly, but that's like okay enough. So I'm drawing a solid line. And then the other one, x plus 2y is less than 4. Let's rearrange this. Was it this color, maybe? I think it was. If I take away x from both sides, we get 2y is less than minus x plus 4. Dividing both sides by 2, I get y is less than minus a half x plus 2. So I'm going to draw the line for y equals minus a half x plus 2. So let's just draw a little table of values. I'm just going to pick a few different values here. So if x is equal to 0, let's just go with that. Then y is going to be equal to 2. If x equals 1, y is minus a half times 1, which is minus a half, plus 2, which is, well, 2 minus a half is 1.5, or 3 over 2. If x equals 2, then y is equal to minus a half times 2 is minus 1 plus 2, which is 1. Okay, I think that forms enough of a pattern there. So x equals 0, y is 2, x equals 1, y is 1.5, x equals 2, y equals 1, so that's another matching point. And we're going to draw this one as a dashed line because of the strict inequality. So like that. Okay, and then we can clearly see the region that satisfies all three inequalities, well, greater than 0 means to the left of that red bit, so here is good. It's also above the green line because y is greater than or equal to the x, and it's y is less than minus a half x plus 2, so it's below the line, so it's this region here. So this is the region that we want. Sometimes they might say label it with R, so I'm just going to use an arrow to say that is the region R. And there we go. Let's move on to the next question. Oh, this ruler needs to be removed, doesn't it? Right, next we've got this graph, and it's saying to work out the gradient of the line L. Well, to work out the gradient, we just pick 2 points, and we use the formula change in y over change in x. Or for some that are used to it, it's y2 minus y1 over x2 minus x1. So let's actually pick 2 coordinates. Well, I see here that we've got the coordinate 0, 80 rather. And we've got another coordinate. Where can I pick another coordinate? This one looks nice. So that's 20, 120. So if I were to pick, let's say, oh dear. If I were to pick this, let's call this x1, y1, x2, y2. Doing y2 minus y1, I get 120 minus 80 over x2, which is 20 minus 0. That gives 120 minus 80 is 40. 20 minus 0 is 20. So 40 divided by 20 is 2. So the gradient is 2. And it says work out the equation of line L. Well, we can see on the graph that the y-intercept is 80. So y-intercept equals 80. So of course our straight line has the form y equals mx plus c. And we know that the gradient is 2, so y equals 2x. And the y-intercept is 80, so plus 80. That's it. Y equals 2x plus 80. Let's move on to the next question. Next, Beth has a full paddling pool. The graph shows the depth of the water in the pool in centimeters over time. So we can see here that this is like a y equals mx plus c graph, but a real life graph. It says the graph intersects the vertical axis. So the vertical axis being this one, like the y-axis essentially, at 70. What does this represent? Well, okay. So it says it represents at the beginning, because that's when t equals 0. At the beginning, gosh, I hope I spelled that right. At the beginning, so i.e. t equals 0, the depth of the pool, is 70 centimeters. So I've said at the beginning because that's when t equals 0, right? When we start. Find the gradient of the line. Well, again, we pick 2 coordinates. So I'm going to pick this 0, 70 because why not? And then I'm also going to pick, I don't know, let's pick this one because it's kind of nice actually. 260. That's that coordinate. So again, I'm going to call this x1, y1, x2, y2. So using the change in y over change in x, or y2 minus y1 over x2 minus x1, we get y2, which is 60, take away y1, which is minus 70, over x2, which is 2, take away x1, which is 0, which is minus 10 over 2, which equals minus 5. So minus 5. Okay, so then explain what the gradient represents. So the gradient represents basically how quickly the water is being emptied, or the rate at which the water is going down. So it represents well, first of all, we can see after each second, the depth of the pool, or depth of the water in the pool, decreases by 1 centimeter. So it's essentially, it's that, and it's basically, I'm talking about the rate at which the depth of the water in the pool decreases. Okay, that is it for this part. I'll see you in the next part, guys.